Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Welcome to this comprehensive tutorial on Apache Singa, a powerful open-source platform for distributed machine learning. Whether you're a researcher or an engineer working with large-scale models, Singa provides the tools you need to train and deploy efficiently. In this video, we'll explore its architecture, key features, and real-world applications. Why choose Apache Singa over other frameworks? Singa is specifically designed for distributed environments, making it ideal for training large models that don't fit on a single machine. It supports various machine learning paradigms, including deep learning, and offers flexible deployment options for both cloud and edge computing. Apache Singa's core features include support for both synchronous and asynchronous training, which allows you to optimize performance based on your infrastructure. Its modular architecture makes it easy to extend and customize, and it provides APIs in both Python and C++ for maximum flexibility. The architecture of Apache Singa is built around three main components: the core engine, which handles computation, the communication layer, which manages data flow between nodes, and the user APIs, which allow you to define and train models. This separation of concerns makes Singa both powerful and flexible. Apache Singa supports both synchronous and asynchronous training paradigms. Synchronous training ensures consistency across all nodes but can be slower due to synchronization overhead. Asynchronous training, on the other hand, improves speed but may introduce some inconsistency. Singa also supports hybrid modes for more complex workflows. In Apache Singa, models are defined using a layer-based approach, which makes it easy to construct complex architectures. You can also define custom layers for specialized tasks. The framework includes built-in optimizers and loss functions, but you can also implement your own for greater control. Data handling in Apache Singa is streamlined with built-in data loaders that support various formats. It also provides tools for working with distributed datasets and allows you to create flexible preprocessing pipelines to prepare your data for training. Setting up distributed training in Apache Singa involves configuring a cluster, submitting jobs, and monitoring progress. The framework also includes fault tolerance mechanisms to ensure that training can recover from failures without losing progress. Apache Singa is optimized for performance with efficient memory management, support for both GPU and CPU acceleration, and scalable communication protocols that reduce overhead in distributed environments. These features make it suitable for training large models at scale. Compared to TensorFlow and PyTorch, Apache Singa is more focused on distributed training and offers a modular, lightweight design. While it may not have the same level of mainstream adoption, its flexibility and performance in distributed environments make it a strong choice for specific use cases. One real-world use case for Apache Singa is in e-commerce recommendation systems. By training scalable models on large user datasets, companies can deliver real-time, personalized suggestions. Singa's flexibility allows it to integrate seamlessly with existing data pipelines and infrastructure. Apache Singa is also popular in academic research due to its flexibility and support for novel training algorithms. Researchers can experiment with new models and training techniques without being constrained by the limitations of more rigid frameworks. The Apache Singa community is active and growing, with regular updates and improvements being made to the platform. While the documentation may not be as extensive as some other frameworks, there are plenty of tutorials and resources available to help you get started. Getting started with Apache Singa is straightforward. You can install it via pip or build it from source. Once installed, you can set up a basic training script and explore the examples provided in a repository to get a feel for how the framework works. For advanced users, Apache Singa offers features like custom optimizers and loss functions, support for reinforcement learning, and capabilities for deploying models at the edge. These features make it a versatile tool for a wide range of machine learning tasks. Performance benchmarks show that Apache Singa scales efficiently across multiple nodes and utilizes resources effectively. In many cases, its performance is comparable to mainstream frameworks, especially in distributed training scenarios. The communication layer in Apache Singa is responsible for handling data synchronization between nodes. It supports various network protocols and is optimized for low latency, which is crucial for efficient distributed training. Apache Singa includes robust fault tolerance mechanisms, such as checkpointing for recovery and automatic failover. These features ensure that training jobs can continue even if individual nodes fail, maintaining consistent state throughout the process. The Python API in Apache Singa is designed to be intuitive and easy to use, with support for high-level abstractions that simplify model development. It also integrates well with popular libraries like NumPy and Pandas, making it easy to incorporate into existing workflows. For performance-critical tasks, Apache Singa also provides a C++ API that offers low-level control and direct access to the core engine. This makes it ideal for applications where performance is paramount and fine-tuned optimization is required. Apache Singa supports various deployment options, including cloud, edge, and hybrid strategies. This flexibility allows you to choose the best deployment method based on your specific requirements and infrastructure. In edge computing environments, Apache Singa's lightweight design and efficient resource utilization make it an excellent choice for real-time inference. It's optimized to run on resource-constrained devices, making it ideal for IoT and mobile applications. Memory management in Apache Singa is designed to be efficient, with support for large models and automatic garbage collection. This ensures that your training jobs run smoothly without running into memory issues, even with complex models. Apache Singa provides native GPU support with efficient CUDA integration, allowing you to scale your training jobs across multiple GPUs. This significantly speeds up training times for large models and complex datasets. Apache Singa includes a variety of built-in optimizers such as SGD and Atom, and also supports custom optimizers for specialized use cases. You can configure learning rates and other parameters to fine-tune your training process. Singa provides a range of built-in loss functions suitable for various machine learning tasks. You can also define custom loss functions to meet the specific needs of your models, giving you greater flexibility in your training workflows. Apache Singa supports a variety of layer types, including dense, convolutional, and recurrent layers. You can also create custom layers to implement specialized functionality. These layers are modular and reusable, making it easy to build complex models. Monitoring and logging are essential for tracking the progress of your training jobs. Apache Singa provides real-time metrics, detailed logging for debugging, and integration with visualization tools to help you understand and optimize your models. The checkpointing system in Apache Singa automatically saves the state of your training jobs at regular intervals. This allows you to recover from failures and resume training from the last saved checkpoint, ensuring that your progress is never lost. Data parallelism in Apache Singa allows you to efficiently distribute data across multiple nodes, making it scalable for large datasets. This approach is particularly useful when training models on massive amounts of data that cannot fit on a single machine. Model parallelism in Apache Singa allows you to distribute different parts of a model across multiple nodes. This is ideal for training very large models that exceed the memory capacity of a single machine, ensuring efficient resource utilization. Managing a cluster in Apache Singa is straightforward, with tools for easy setup, resource allocation, and monitoring. Whether you're running on cloud infrastructure or on-premise hardware, Singa provides the flexibility you need to manage your distributed training jobs. Apache Singa integrates seamlessly with big data tools like Hadoop and Spark, allowing you to incorporate distributed machine learning into your existing data processing workflows. This makes it easy to scale your machine learning tasks alongside your data infrastructure. The future roadmap for Apache Singa includes enhanced support for reinforcement learning, improved edge deployment capabilities, and better integration with cloud platforms. These developments will further solidify Singa's position as a leading distributed machine learning framework. When working with Apache Singa, it's important to avoid common pitfalls like overloading nodes or using inappropriate batch sizes. Monitoring resource utilization and following best practices will help you get the most out of the framework and ensure smooth training processes. In conclusion, Apache Singa is a powerful and flexible framework for distributed machine learning. Its modular design, support for various training paradigms, and scalability make it ideal for both research and production environments. Whether you're training large models or deploying at the edge, Singa has the tools you need. Thanks for watching this deep dive into Apache Singa. If you found this tutorial helpful, please like, subscribe, and comment with any questions or topics you'd like to see next. Don't forget to explore more tutorials and join the Apache Singa community to stay updated on the latest developments. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.